I'm going to talk about removing radicals from denominators. Let's start out with the following example. Suppose you wanted to express this quantity in an equivalent format that did not have a radical in the denominator. We know that we could multiply by 1 and that won't change the value. Let me express 1 as a fraction with the top and bottom, the numerator and denominator being the same radical. All right, now go ahead and do the fraction multiplication, and lo and behold, we have a form that does not have a radical in the denominator. Something similar can be done if you want to remove fractional exponents from denominators. All right, so we know that that's equivalent to a 7 to the 1/2 is equivalent to the square root of 7. Okay, so for this example, we do something that corresponds to what we did before. We're going to multiply by 1, but I'm going to express 1 as a fraction with the top and bottom being what I need to do the desired fraction multiplication to get the answer that I want. Okay, so if I multiply by 7 to the 1/2 over 7 to the 1/2, look at what I get. I get 7 to the 1/2 over 7. So I get an equivalent expression that does not have fractional exponents in the denominator. Okay? Now I would like you to try 2 examples. Would you please find an equivalent version of 3 over root 5 and 5 over 11 to the 2/3? So I want you to find equivalent versions that don't have radicals and don't have fractional exponents in the denominator. So pause the video and do that now, please. Okay, so I'll go ahead and work that out like I did the other examples. I'm going to multiply by root 5 over root 5 for the first exercise, and that'll give me 3 root 5 over 5. The second example, I'm going to multiply by 11 to the 1/3 over 11 to the 1/3. And notice I didn't multiply by 11 to the 2/3 over 11 to the 2/3, because that wouldn't have met my goal. Okay, and so then I get this for my answer. 5 times the cube root of 11 all over 11. Okay, now there's another situation you might have to deal with. Let me show you an example of that now. Suppose you had 1 over the sum 1 plus the square root of 2. And suppose you wanted to find an expression equal to that didn't have a square root in the denominator, a radical in the denominator. For this example, we can't just multiply by root 2 over root 2. You can try it, but you'll see that it won't give you what you want. For these types of examples, you're going to want to multiply by 1 again. You're going to want to multiply by 1 expressed as follows. 1 minus root 2 over 1 minus root 2. Okay? In other words, if your denominator is something plus a radical, you're going to want to multiply it by something that involves that something minus the radical. Okay? This is referred to as the conjugate. Okay? So the conjugate of 1 plus root 2 is 1 minus root 2. Now notice when I do this fraction multiplication that everything will achieve our goals. So on the bottom I have 1 plus root 2 times 1 minus root 2. That should remind you of the difference of squares patterns. Difference of squares pattern. You can work that out and you'll see it's equal to 1 squared minus root 2 squared. Okay, so the whole thing simplifies to 1 over root 2 all over 1 minus 2. So square root of 2 minus 1 is the best I could make it. Okay? Now, if you have a difference in the denominator, then you do something similar. 4 over 3 minus root 3. I'm going to multiply by 3 plus root 3 all over 3 plus root 3. Okay? So the conjugate of 3 minus root 3, for that example, the conjugate is 3 plus root 3. Notice I still change the sign. Okay? So that's going to give me 12 plus 4 root 3 on top, and 9 minus root 3 squared on bottom. That simplifies to 12 plus 4 root 3 all over 9 minus 3. So on bottom we have a 6. So this, let's see, so I can get a 2 plus 2/3 times the square root of 3. That's the best I can do. All right. Now, I'd like you to try one. So, would you please try to find an equivalent expression for 14 over 5 minus the square root of 11. Okay, so again, give me an equivalent form that does not have a radical in the denominator. So pause the video and do that now, please. Okay, I'll go ahead and work it out as well. So I'm going to multiply by 5 over root 11 over 5 plus root 11 over 5 plus root 11. And that's going to give me, let's see, 14 times 5 is 70. 70 plus 14 times the square root of 11. And then on bottom, 5 squared minus the square root of 11 squared. So 70 plus 14 times the square root of 11 all over 25 minus 11. 25 minus 11 is 14. So let's see, that gives 5 plus the square root of 11.